All right, I think I left off last time with the formula for variance, and I'll write it on the board here in just a minute. But I told you that I would start presenting with a spreadsheet. And notice I said presenting. I didn't say forcing you, twisting your arm. I didn't say anything like that. I use this to present with. So I want y'all to take it as presentation. Now, if you're one of these people that like the spreadsheet, that's good. Use it. I don't care. But some of these people that don't know how to use a spreadsheet, don't go to my department head and tell her that I'm forcing you to use, because I ain't forced you to do anything, okay? You ain't got to do anything but die and pay taxes. All right, so with that being said, let's go ahead and write down that data set that I've got written down there. Here's the data set, and I've already put it in order for you. And those consist of 5 numbers. Now, if you look at the top, n is equal to 5. That means that there's 5 test scores. We're going to say test scores so everybody can relate to it. I put them in order because that's the first thing you're supposed to do. So everybody needs to write those down. And of course, we're going to do everything by hand, and then I'll show you how to do it, on your calculator, which some of y'all calculator drill team members, y'all twirl that thing around on like a basketball on your fingers, you know how to do it. So they beat you over the head with it in high school till you tell you that you're going to need it in college. That's what they tell you. All right, so you take the handy-dandy formula that I gave you, and I think I gave you variance is equal to the summation of x minus x bar quantity squared over n minus 1. And we've got these other things to get over here. But I put this one up here because that's the one everybody's going to forget or get confused with. So, let me move that because it's in the way. You got your mean. Your mean is also called what? Average. It's also called x bar. It's also called mu. I'm trying to think of any other names it's called. And I also call it x bar in the spreadsheet. Like that, because it's too aggravating to bring the symbol in, and the symbol really doesn't look like the symbol, so I don't use it. The median. What is the median? The median is the what? The middle. If n is odd, you find the middle. If n is not odd, if n is even, what do? You average the two what? Middle numbers. So write that down because I didn't have enough room to write it. If n is odd, you find the middle. If n is even, find the average of the middle two numbers. Or you quit. Throw your pencil down, make it pop. All right? Mode. Well, mode's pretty simple. It's useless, and it's the easiest one to find. And if you miss the mode on a test, you don't tell anybody. The mode means what? The most. Can you have more than one mode? Yes. You can have a set of data that's bimodal. You can have a set of that's 2. Monomodal, which means 1. You can have trimodal, which means 3 modes. And you can have polymodal, which means more than 3. The main thing, there's 2 things that you need to know about the mode. One, you never put 0 for a mode. You never say, okay, I don't have any modes, so I'm going to put 0. You never do that because you're always going to have an SA teacher that's going to go, oh, well, 0 is not even in the data. Okay, so never put 0 when you mean none. Always write the word none, non-applicable, ain't there, does not exist, D and E, whatever you want to put, but do not put 0 for the mode. Some students have done that, and the teachers mark it wrong. All right? The second thing you need to know about the mode, if you have 3 numbers that show up the exact same amount of time, then you write down all 3 numbers. All right? if 25 shows up 3 times and 32 shows up 3 times, and that is the most, then you have to write down both 25 and 32. Okay? So don't be, and like I said, does the mode have really any mathematical value? No. The reason I include it is because the homework includes it as well as the test. So I really don't care anything about the mode. It's the only one that's observed. You do not calculate it. Range. What's the range? Highest minus the what? I don't know why. That is the wrong button. Let's see. Highest minus the lowest. Okay, I thought I hit it. I got to sit here and hit it 3 or 4 times, I guess. Highest minus the lowest. Again, if you miss the mode or the range on the test, you don't need to tell anybody. Mid-range is the average of the high and the low. You take the high plus the low and divide it by 2. Some of you remember the midpoint. Midpoint's the same thing. It's the middle, and you need to write this down because the mid-range doesn't have really a mathematical value you can use it to compare with because it's the actual middle. Okay, some people say the median is the middle. The median is the calculated middle. Okay, a lot of people go, what do you mean calculated? The median takes in effect all the numbers around the center. The midpoint, it's just the middle. Think of the middle of the number line. If you got a number line from 0 to 10, what's the middle? 5. Okay, did you calculate it? No, it's the middle. And that's dependent on the median. The median is dependent on the middle 2 numbers, or the middle number, and I can't even think of the word. The mid-range takes in account the high and the what? The low. So think of this as the middle of your number line. The reason I say that is when we do box plots, that's what you're going to use for to draw on. It's the number line. It's going to have your high and your low and your midpoint, or your mid-range. And then you're going to draw your box plot on the number line, just like you did, with things on number lines before. And the variance. Well, the variance and standard deviation, I'm going to just leave it to this. And we're going to read that as we're doing the variance and standard deviation, because that's what you need to do when you get stuck. You need to read the actual formula. All right. So let's go ahead, and the mean is, let me get rid of this. The mean is 72, and I'm going to just go over here and do that because I want to calculate all the numbers. The mean's not 72. The mean is the summation of what? What do we do? Add them all up and divide by what? N. Good. So take my handy dandy mouse and go over here. Equals. No, I'll just hit sum. And go down and do those numbers, and then I'm going to divide by N. Now, a lot of you say, well, why is he picking the cell with N and not just putting in a 5? Well, you'll see on the next spreadsheet that I fix numbers for 5, 6, and 7, and it reads that number. It's just something, that I do. I mean, it doesn't matter. But on other spreadsheets, that number may change, and you've got your formulas dependent upon that number. So that's why I use the cell versus the number 5. And there is our mean, which is also called X bar. Okay, the median, I'm going to change this back to white and change this to, and change that to that. So there is your median. Why did I pick the number? Because what is N? N is 5, which is what? Odd. Mode. Well, I ain't worried about it, but there is none. So you put D and E. Range. That's going to be your highest minus your what? Lowest. Mid-range is equal to, parentheses, your highest plus your lowest divided by 2. Variance. Well, we're going to talk about that in just a minute. Now, I want everybody to look at these 3 numbers. The mean, and we'll color that verde. Median, verde, and the mid-range. Now, in this case, I would ask you, in many other cases, I would ask you what is in common with these 3 numbers. Well, not really in this case because of that 95 and that 72. All right, the 72 mostly. Look at your data. What type of student is this student, you think? That's not rhetorical. I'm asking y'all for input. Okay, it's either A, B, or C student. It's not a F student. What is it? What type of student is this student? I would say a high B, a low A student. So what does that say about the 72? Outlier. And it's going to throw your data out of wampus. If you don't know what out of wampus is, it's your parents' fault. Out of balance. You ever put towels in a washer and it get on one side? You ever done that? Y'all ever wash clothes? Okay. All right. What does it do? It starts going blah, 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 and it starts doing something funky, okay? That's called out of wampus, out of balance. And that's what happens when you have an outlier. Watch this. What if I change that outlier number right there to an 80? Watch those 3 numbers over there in green. Okay, what are they starting to do? They go up, but what are they starting to do as far as each other?
Become closer to being equal.
Exactly. When those 3 numbers are equal, that means are close to being equal, that means your data is valid. Write that down. When those 3 numbers are, I don't know what you call, converging on each other, or when they are similar. Now, I give it 1 or 2 or 3 points. After about 3 points, if there are 3 points difference, then you start to worry about your data. So me just throwing that 80 in there, when I threw the 80 in there, it made the mean within what? 1.8, and then the mid-range within 2.5, okay? You start to see the data get closer and closer. Or the data means valid. It's called tight. Your data is tight. The opposite of tight is slack, not tight. All right. If I was to throw 2 outliers up there, let's say that, well, you can't throw an outlier on the top side because let's say the student came in drunk, took a test, and made a 60. All right. Now look at your 3 numbers. Now, why in the heck do you need to know that? Because somebody's presented that way, somebody's presented the data, and you see those 3 numbers out of whack. Then you know that the data, something is wrong with the data, even though they haven't even shown you the data. Again, it's all about perception. You need to know if you're being presented this data, or if you're doing it yourself, you need to know if those 3 numbers are not together, then you've either got outliers that you need to address or you need to present, or you need to cut out the outliers. When I was at Clemson and I was in civil engineering, I had to take three or four physics classes, okay? Just like any engineer, math, science person needs to do. And in one of our classes, I can't remember, 1, 2, or 3, I know the third one's called heat and sound, time and temperature, whatever. One of them, we had to make a car out of a mousetrap. Okay, and you know, you have your labs, you all know your labs, you have your lab partners. Well, there was 4 of us, and we took this mousetrap and we harness the energy out of the spring by using a string and a pulley system, and that sucker would take off. All right. We ran the trial 15 times. Now, why didn't we run 10 times? Because we used the 15 for when it would run off the track and run into a chair. All right, that was one time that we don't count. So you knock out some of your outliers, which is running into a chair, and you use the 10 best measurements of your data. Now, some of you may be in biology lab, some of you may be in chemistry lab, some of you may be in the physics lab. But the whole point is, you never take every single one of your data, okay? You drop it down. If you run the data 15 times and you want to take 10 times or 12 times, throw out your 3 that are messed up, or throw out your 5 that are messed up, and use the 10 best measurements that you got, or the 25 best measurements that you got. And if you take it to a survey, if you've got 100 surveyed, you might want to survey 125, so you can throw out 25 that may be outliers. And how do you determine if they're outliers? Well, right there it shows you. So include everything and then knock out whatever throws those 3 numbers out of Wampus. And that's why the big number rule, or the large number rule, is so important. If you're a Michelin executive and you're quality assurance, you're not going to pull 15 tires out of each. You're going to pull 500 or 5,000. Big numbers are better. Okay? So remember those 3 numbers. Now, let's go ahead and do the variance. Now, first of all, read your formula. Let's use our basic math skills. Please excuse my dear Aunt Sally. What do you do first? So what's inside the parentheses?
X minus X bar.
Okay, so what does that mean? That means words. You're going to put together some words. What do you do?
Sum of X minus the X.
Okay, no, I'm just talking about the inside. X minus X bar. What do you do? Tell me in a sentence what you do. Okay, the sample, or the X minus the what? The mean. All right. Now, the reason I asked somebody to put it in a sentence, how many of you did that? Maybe one that actually exerted their voice and told me. All right. Some of y'all are saying, what are you talking about? Okay. You take X bar, which is the mean, and you subtract it from each one of the values. That's what I was looking for. All right. Don't just look at the X minus X bar and go, I don't know what the hell that means, but you know. You need to know what it means. All right, so X minus X bar. So I'm going to have a column here, and I'm going to call it X minus X bar. And equals 60 minus that number right there, F4 to lock, for those people that know what that means. If you don't know what it means, you don't need to know. There you go. And now copy that down. Now, each of you do that right now on your column in your notes. And the reason you need to copy all this down and write notes is whenever you get home and try one, you don't get cold and you don't know what's going on. So under here, somewhere down here or up here, you need to say subtract the mean from each value. Okay, please excuse. What does excuse stand for? So after I subtract the mean from each value, what am I going to do to that? Square it. Good. That's good. You're reading my cues. I wanted y'all to interact with me. Thank you. Got 2 people that are awake this morning. X minus X bar, quantity squared. You know, it must be hell in some of y'all's high school classes where you don't talk, you don't do anything, you just stand there. I mean, you just sit there. That's awful. I don't see how you stand it. Of course, I didn't do it when I was in high school, but we were supposed to, but I didn't do it. But I just can't imagine sitting through a class for what, an hour, or is y'all's classes an hour and a half? Oh my God. No wonder y'all are conditioned. It's awful. Raise it to the second power. Just sit there and be robot. Don't say a word. Don't think. Just there you go. All right, now we have just done, take your handy dandy highlighter, virtual highlighter, and I'm going to use dang old Aquamarine. I love me some Aquamarine. Let's see. Anybody know what movie that came from?
No.
Huh?
I know there's a movie called Aquamarine.
No, there's a guy in there that goes, I just love me some Aquamarine. Lone Ranger, which was a stupid ass movie, but it had Johnny Depp in it, so it wasn't that bad. All right, I just did x minus x bar, and what else did I do? I squared it. Okay, now, there's only one thing left to do in the numerator.
Add it all up.
There you go. So you take your handy dandy mouse, virtual mouse, I don't know what's wrong with this thing, and hit summation, go down to the cell, right here. Somewhere I got summation over here. I want to line it up right. There we go. And add it up. And everybody's numerator is 782.8. That's your numerator. That's this blue area right here, or aquamarine.
Did you mean to leave 60 in there? Or-
Yeah, it don't matter. It don't matter what it is. Yeah, it doesn't matter. Yeah, because in just a second I'm going to show you the benefits of having a Excel spreadsheet. You just punch the numbers in and you're done. So, but thank you for paying attention. I appreciate that. Just make sure you do that if I make a mistake. Don't wait till I go through the whole problem and say, oh yeah, you made a mistake, and then all the class goes, yeah man, I don't know why you made that mistake. I thought you made a mistake 20 minutes ago. Love it when students do that. Actually, it really makes me mad. If I make a mistake, tell me right when I do it so I don't have to go through the whole thing again. And Bubba's on the back row going, yeah man, you stupid. He don't even know what day it is. Equals this divided by what? Now y'all should be able to get this. N minus 1, which is 4. And if you get that wrong, don't tell anybody. And your variance is 195.7, which really does not mean a thing to you. Okay? Later on, if you take another statistics course, a more advanced statistics course, you will use it. But right now, you don't. And many of you remember from Math 120 in high school, whatever it's called, probability and statistics, whatever, that what is the relationship between the variance and standard deviation? Thank you. I didn't hear you. I only heard a little bit of it, but the standard deviation is the square root, so raise it to the 1/2 power. So take your variance and raise it to the 1/2 power. And your standard deviation is 14. And I'm going to add that to the green list, meaning that it's very what? Very important. The two most important numbers in probability and statistics are what? The mean and the what? Standard deviation. The others are important, but these are the most important. Because you can't understand statistics if you don't have the mean and the what? Standard deviation. And I'll tell you what that means in just a minute. So now, if you have one of these in your spreadsheet, then you can go, well, I made a 92, a 95, a 96, a 98, and a 100. And now you've got your, and it's a little bit primitive, but you'll see when we do some of the homework problems, you'll see how much work doing the Excel spreadsheet will take out of your taking a test or homework, because you can put the data directly into the spreadsheet versus having to type it in your calculator and put it in order, which you have to do two separate things. Okay? And look what happened when I changed those to more comparable grades. Look at the mean, the median, and the mid-range. Again, tells you the data is tight from a presenting standpoint or a calculator standpoint. In other words, if you're calculating the data, it tells you that. If somebody puts the data on the board and you're in a student, observer position, then you know the data is pretty tight. What if the teacher, y'all seen teachers put up that information for a test on the board? Have y'all had a teacher do that? Do they even do that anymore? And after a test, the teacher will put up all that data on the board. Okay, I don't know. But let's say a teacher puts that data on the board, but they don't show you the test scores. Let's say 47. Let's say there's 5 people in the class. Okay. Let's see, 47, 72, 75, 76. And of course, there's always 105 that makes 105. There's always one. Look at the data over there. You got a 76, a 75, a 76, and a 70, or 75, 75, 76. Now, why is the data close? Because your 2 outliers, your 3 middle numbers are very close, and then you got this, the 5 points kind of offset, or the 35 points, or 30 whatever points, 29 points that offset that one. If you add 29 to 47, what do you get? 76, don't you?
Yeah.
Something like that. All right? That's why, because that 29 points there, from 76 to 105, that's 29 points. If you added that, took it off of there and added it to that, you would have decent numbers. But let's say you didn't have that one person in the class. Let's say that you got a 72, a 75, a 76. Well, let's do a 56 here. 72, 76, and a 74, or 77. Look at your numbers now. So if your teacher just put up the right side over here, let's say there's 5 people in the class, and he put these numbers up, then you would say to yourself, something's wrong with the what? Something's wrong with the data. That means something's wrong with your teaching, something's wrong with the class, or something's wrong with the test. Because the data should be in what? It should be in line. It should be in some kind of line. And yeah, you're going to have the deadhead that makes a 42 on a regular test, and you're going to have the genius that makes 105 on a 100-point test. Okay, you're going to have those 2 people. But when you get more than those 2 people, then something is wrong. And that data, those 3 numbers in green over there, not standard deviation, those 3 numbers compared will say, okay, something's funky going on. Because they should be 66, 65, 67, and then 64, 65, or, they should be within 1 or 2 points of each other. Okay, so if you don't take anything away from today's class, I want you to take 2 things away. 1, you have to look at those 3 numbers and determine whether the data is decent. 2, make sure you understand that the mean and standard deviation is what you build on for the rest of the unit for statistics. Okay? Not probability, but for statistics. So what if we have 6? Well, let's go down. We can copy that, but I don't want to. Well, let me clear off the board first. And we can copy it. Let me, this thing gets in the way sometimes. Let's go here. And again, the reason sometimes you do this is because it's very easy to copy. Go down here, paste, and we'll insert a line right here. And let's say x is equal to 6. And go ahead and put these, and that way you'll have an even and an odd. Because, of course, after even and odd is shown to you, there's not really any reason for you to put more in your notes, because that's all you need to know, 1 even and 1 odd. So let's go with 81, 82, 82, 86, 90, and 95. Okay, now you got two numbers right here that's going to make up the mean. Now I'm going to go through and check everything because I don't want to mess up. So auto sum these numbers, and we're going to divide it by 6. All right, I did the mean for you. I want you to go through and do the rest of it by hand. I don't want you using, I mean, you can use your calculator to do the basic math, but I want you to go through and fill out the columns by hand in your calculator. I don't want you, don't go through, the calculator drill team, don't go through and calculate statistics and all that. I don't want you doing that yet. Okay? I want you to actually go through. I did the first one for you. Now I want y'all to go through and see if you can redo that by hand. Everybody's here? Good. Well, I'm going to put it in. Take my truck to the shop, and I ain't got no car, I ain't got no vehicle, so I can buy. I had to get some tires. My tires were about shot yesterday. I got stuck on the farm, had to pull my truck out. I said, bump this, I'm gonna go get some tires. And what I'm most interested in is making sure you can do those columns and you can do the variance and standard deviation by hand with the help of your calculator doing the basic math. I'll go ahead and fill in the columns for you. And you should come out with mean of 86, median of 84, mid-range of 88, and standard deviation of 5.5. Now, why is my median a little bit off of my, well, it's not really off, it's only 2 points. But the mid-range is way off. Well, it's only 2 points. I guess it's okay. But it looks kind of weird because of the difference between the 86 and 84. So the data is pretty consistent. Throw 1 in there. And you see a jump in all 3, and you know something's wrong. Again, what is statistics? Gathering, calculating, and what? What's the I word? Interpreting. You're not given this over here. You're presented with this material. You interpret, oh, something's wrong. Or you are calculating the material, or you are calculating, and you get over here and you say, whoa, 76, 84, and 60? Something's wrong. And then, of course, you know what's wrong, that. But this is more of a presentation observer. Okay, something's wrong. Why is your data out of kilter? How many outliers do you have? Those are the questions you would ask as an observer if you were in a presentation and you saw those numbers. So interpreting data can be from a calculating perspective where you are calculating the data, or it can be from you're sitting in a meeting and you see those numbers not line up. Something's wrong. Okay, now the next spreadsheet I sent or I made up, and this one I might send to you just for you to use. The reason I'll send it to you is because it's read protected, so you can't mess it up, I guess is the best word to say. You can only input this data here, and you can only input that. And like I say, you have 4, you type in, let's say ages, 25, 26, 30, 32, and boom, you got your information. Go down to N5. I only did like to 7. I figured it was good to have 4 examples so you can really, get the information. But why would you go to this much trouble if you, oh, sorry, I forgot to tell you, what is this right here? Well, let me show you what this is. And then we'll talk about the homework problems. Why do you need the mean and the standard deviation? Well, the mean goes in the middle of your bell curve. And get used to drawing these things because you're going to draw 100 of them between now and the end of the semester. So you better get used to it or copy it and paste it in and run some sheets off with 5 or 6 of these on it because you're going to see it again. There's your median, 28.25. I'm sorry. Yeah, your mean, sorry. Thinking of chapter 6. There's that. And there's that. 95%, and you need to look into your, did I already tell you about the empirical rule? Yes or no? All I heard was, Yes. Okay, make sure you turn to your empirical rule on this. 95% of the population is going to fall within how many standard deviations? 2. 99.7% is going to fall within what? 3. So make sure you know that. So 95%, according to this data, is going to fall between 21 or 22 and 35. And that's considered to be, my daughter would say, normal. That's how she said normal when she was little. 95% is going to fall between 22 and 35. Again, that's interpretation. If that data is given to you, then you know you don't know much about the data, but you know that the mean, 95% is going to fall between 22 and 35. Now, how do you get that? I think I've already went over this. Here's the mean. This is mean plus standard deviation. This is mean plus standard deviation. This is that number plus standard deviation. Either you can add it once here and twice here, or you can add it here and then add it to there. Either one. I don't care how you do it. But if you take 3 and add it to 28, you're going to get 31. If you take 3 and add it to 31, you're going to get 34. And that's what you do. That's why these two numbers are the most important as far as your normal distribution. So make sure you can draw that. And on each one of these, I put that so you can picture the normal distribution. Now, if you wanted to carry it to 3, then it would be 34 plus 3 is 30 what? 37, and that would be your 97 point whatever. What's 21 minus 3?
18.
Thank you. 18. Dot, 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 because you got to put the decimals there. All right? So if you want to know your outliers, the outlier, what if you were 17 years old? If you were 17 years old in this class, you would be an outlier. If you were 19, you would be unusual. If you were 35, you would be unusual. If you were 40, you would be what? An outlier. And that is on your empirical rule. Make sure you know that empirical rule. What page is it again?
132 and 110.
132 and 133, whatever the difference is. What's the difference in them? You know? You don't have to look it up. I don't know why they have them on both sides, but just read it and see what the difference is. Now remember, some books and some classes, they do not divide that last percentage. You need to make a note of that in your book or somewhere. And that might be the difference between the two pages. I don't know. But some books, they do not break up that 2.5%. Or they don't break it up. Some books do. I think y'all said it was 2.35 and 0.15. So this is 2.35, and this is 0.15, and this is 31.5 or 11.5. I always get that mixed up. I want to say 13.5. This is 34. This is 34. This is 11.5, or is it 11.5?
13.5.
I see. I do it every single time. I don't know why I do that. 13.5. That's the only number I forget. I don't know why I forget it. I guess I'm brain dead. 13.5, 13.5, and 2.35, and 0.15. That's the difference between a lot of books. Some books, they won't do this. They will just say 2.5 right here, and they won't do this. But, you know, that's basically the empirical rule. And this right here is what you calculate with your mean and your standard deviation. Mean and standard deviation. That's why I've got them circled right there, because that's why they're very important. And you're going to be drawing the normal distribution, except for the next unit, which is probability. After probability, you're going to be going back to drawing it. So, and you're going to draw it all the way up to after Unit 1 test, you're going to be drawing it. So you better get used to drawing. Now, what I tell students to do is go to Google and Google normal distribution curve and do images. Take one of those images, save it as a picture or whatever, insert it into a word processor, copy it like 6 times on a page, run 1 copy, and then run 15 copies of it. Or print out 15 copies of it. Why? So you don't have to what? So you don't have to draw it 5,000 times. Of course, that takes a lot of work. You have to hit print. And then you have to hit print again, or copy. So it takes a lot of work. Some of y'all will do it. Most of y'all won't. And then what will y'all do? The ones that won't, what will you do toward the end of the chapter? You'll complain and bitch about what? Drawing. These people procreate. Okay. So, why do you need to do this? Well, this is why. versus the calculator drill team? Well, let's pull up our handy dandy homework questions. Here's a question right here. Now this right here is a bitch of a problem, okay? I'm going to tell you, this would not be, I would not put this on the test. Now, it's a good homework problem because it's got a lot of data and you have to organize it, but the best thing to do is hit this little button right here. It's a hyperlink, and watch what it does. Copy to what? Excel. Lord, it's a miracle. And now all you got to do is highlight this, highlight that, and oh, I hate this button. I hate that. That's the only thing I don't like about new Excel is that daggum enable whatever. All right, highlight
I
it.
think you got the first one.
Did I not get the first one? Thought I did. All right, highlight it. Go to data. Get this thing out of the way. Go to data and sort. How long will it take you to type that in the calculator and sort it? About 5 minutes. The reason is you have to sit there and go 0.26. I mean, even if the calculator is quick, and it is, but you got to put the data in. Unless you can take a picture with it, and that'd be nice. Okay, but that's the easiest way. The Excel spreadsheet on a test or homework is the easiest and fastest way to do this. Now, if you don't know, then the second easiest would be use your calculator, hit calculate, and we'll do that. We'll do that after I show you the spreadsheet. But let's go ahead and let's do it. Now, I'm not going to ask you to do this in your notebook, but what I'm going to do is I'm going to put mean, median, mode. I'm not even going to care about the mode on this one because there's too many of them. Range, mid-range, and standard variance and standard deviation. Okay, the first thing I want to do is get my mean. So go up here, hit summation. I have no earthly idea how many numbers I got. How many did it say? Okay, yeah. Well, duh. 50 cells, duh. Okay, divide by, and in this case, I'm going to divide by 50. I'm not going to put a cell because chances are, now, what would be nice if you made a template for this, but how many times are you going to see it on homework? I don't know, one time? I don't know. You're not going to see it on test because I wouldn't do that to you on a test. And hit enter, and there is your median, mean. Now the median, like you said, is what? 50, so that's even. So we got to go through and get what? Those two right there. Make sure there's 24 up and 24 down. I think that's it. Click on that. I'm going to highlight it so I don't lose it. Go over here. Equals, parentheses, this number plus this number divided by 2. Mode, I don't care. You can do that on your own. Range is equal to the highest minus the what? Lowest. And remember, if you get that wrong, you don't what? You don't tell anybody. Yeah, I got that one right. Equals, parentheses, your lowest or highest plus your lowest, doesn't matter what order, plus highest, close parentheses, divided by 2. And there's all that information. Now, when it really helps is when you're doing the next one. So I'm going to go up here. I'm going to hit equals this number minus that number, F4 to lock it. Because if you don't lock it, when you roll it down, it's going to read these numbers in for the mean. So you gotta lock it so it'll read the same number every time. Oh, horse pucky. Damn Russians. There we go. All right, now what am I going to do to the next column? Second power. Raise to the second power. And copy down. You're going to get a summation of that. So go down here, sum it, enter, and there's your numerator. So go up here, equals that, divided by 49, and then take the square root of that, raised to the, raised to the 0.5 power, and you got that data. Now, of course, you can take your standard deviation, your mean, put it right there, equals this number plus the standard deviation, F4, and then copy that thing out as many as you want to, but usually 2 or 3 is what they're going to ask for. This daggum mouse I'm going to take it to 3. And then right here equals this number minus the standard deviation, F4, and I'm going to copy that over. 2, 3. So 95% of these numbers are going to fall, should fall between 72.72 and what? 0.97. And that's how you do that. But now, if you go through the trouble of doing this one, shouldn't you save it until you finish your homework because you might get another one with 50 in it? Yes. And then all you would do is you would go back to your homework. Let's say we're going to save this as something. I don't care, just save it. Okay, whatever, because it's read. Oh. Okay, why is it read only? I didn't make it read only. Oh, whatever, just do it. Save it. You're going to save it. Copy of data. Okay. Now, if you come up with another one, and this is important, right here, pull up your question. You go here, and if you already have a spreadsheet with 50 in it, then you just copy the clipboard. And then you just done, and go in here and hit paste. Well, it's supposed to, well, okay, yeah, that's right. I forgot. Yeah, this is the one I pulled up. I'm sorry. Okay, so anyway, to make a long story short, you copy and paste. Now again, it's faster than the calculator, but it's robbing Peter to pay Paul. You take the data and you can put it into the computer faster, but what do you have to do over here? You have to actually do the calculations by hand by putting it in there, where your calculator does the calculations, but you have to do what? You have to put in the input. So it's 6 of one, half dozen the other. So it's up to you what you want to do there. So in this case, the next question we got, and I hope that answered, whoever sent that question in, I don't know what the question was. Let me see what the question was before I go on. Let's see. Determine the sample standard deviation. Okay, I did. It's, what did we say it was? 0.06265. 0.06265. See what it says round to. Nope. 0.062 or 3. And check answer. And we feel good about ourselves. So we don't wear sunglasses in the gym. Oh, what the heck is this? On the basis of a histogram, comment for using the empirical rule to make, we did that. Histogram is, well, let's do a histogram. Dang old, take these data right here. Okay, what are you doing? It's not working. The Russians have invaded my spreadsheet. Okay, now it's done totally something screwed up there. Oh, Lord. Now, go up here to Insert. You do whatever you want to. I don't care. Scatter plot. Where's scatter plot? I don't see it. There it is. You can do a scatter plot like that. I don't think that's what they're wanting though, but I think what they're wanting is the empirical rule. That's what the data looks like. It's increasing is about all it's doing. There's a slight correlation, but I don't think that's what they want. I'm trying to figure out what they want. Let me go back to the question and see what they're wanting. On the basis of the histogram to the right, sorry. Is this a normal distribution? It is close. The only problem is this guy right here is not like this guy. So you would say it's probably close. The histogram is approximately, not approximately, approximately, not approximately. So I would say approximately. This is one of those Philadelphia lawyer questions. I don't like these questions. I like these up here that you find the math. That's what I like. I would say it can be used because it does. That only problem though is this one right here. That one right there is not symmetrical to this one. It's symmetrical to this one, but it's not. So it could be either A or C, depending on who wrote the question and what the moon was the night before. Okay? Oh, really? I hate these 5-part questions or however many parts this thing got to it. 3 remaining? That's ridiculous. Use the empirical rule to determine the percentage of candies with weights between 0.72 and 0.97. All right, 0.72 and 0.97. You have to blow this thing up. 0.72 would be right in here. I'm going to say 95%. No, not 95 because this is 95, I think. This is not a good question. 0.72 would be right in here. And what did he say, 0.96 would be right? I'd say 95% of the population, but I don't know what the... Using the empirical rule would be 95, but... Okay, my numbers don't work. What's wrong with my... Okay, I can't type in.
I'm gonna leave the rule.
Huh?
I think it's my fault.
It is. That's why everything happens to us. It's your fault. No, I just turned it on and off. There. I guess I had to turn it on again. Whatever. Oh my God. Determine the actual percentage of candles that weigh between. Okay, I'm gonna let y'all do this. This is redundant. 0.772 and 0.96. Didn't they just ask that?
They want actual, not the empirical rule.
So they want you to
Oh, well, you got to go through and count these. So 0.72 and 967. 0.72 and 967. Oh my gosh. 0.72 and 967. .967 is really 0.97. Okay, how many is that? It's 1, 2, 3, 4. There's a 3. So that's 47 over 50. I'm not going to worry about that. This is ridiculous. The question's not ridiculous. The person sending, I'm not talking about you. It's just 15. What is 47 divided by 50? Somebody give it to me. 0.94. They probably going to count that 0.97, which would be... Okay, they didn't. Oh. Okay, y'all get how to do it now. Okay, I'm not gonna do all this. All right. Yeah, I ain't worth crap. All right. I'm just making sure. What time's class over? 9:20 or 9:25?
25.
9:25. All right. Now, this one. All right, you can do this one by hand. Got to use a little bit of algebra now. The median for the given set of data of 6. What does 6 mean? 6 is what? That means n is equal to what? Is even. So that means the average of the two middle numbers is equal to the median. Right? So that means we got the two middle numbers is 21 plus x divided by 2 is equal to what? 26.5, Hubert. That's right, class. Now what? Multiply by 2. 21 plus x is equal to what? 53? Somebody help me out. 53. X is equal to 53 minus 21. And that's 30 what? 32. So x is 32. A little bit of pre-algebra there. All right, that's 2 questions for homework. Who else got questions on what we went over today? Not, if you know how to use your calculator, that's fine. You can use it. But right now, everybody should be working on up to whatever section homework this is. I have no idea. Somebody tell me where it gets into the mean standard deviation. I think it's 3.2 or 3.3. What were those questions from?
That was from 3.2.
Okay, so everybody should be working on homework, chapter 1, chapter 2, and chapter 3 up to 3.2 after today. Okay? Y'all get out of here and have a good day. If you got any questions, I'll be up here. And I'll see y'all whatever day y'all come back.
Thursday.
Thursday. Thank you.